Okay, welcome. Apologies for running a little bit late. We also have an engagement in Santa Monica, and most of my engineering staff is down there. We've partnered with a company called Pivotal Labs. We are rewriting our iOS and Android clients with them using a lot of XP practices, Agile, so it's a lot of exciting stuff, but what that means is that I'm kind of commuting between two offices. Okay, so today we'll talk about building global mobile cloud architecture, and maybe before we start, how many of you actually write code? Okay, so we've got people who write code. How many of you do actual cloud architecture? A few of you guys? Okay, great. And how many of you actually do mobile stuff? Okay, great. So we have a good mix. Today I'm going to focus on some of the pitfalls of building mobile applications and then deploying them into a global market. We'll kind of take a deeper dive in terms of what you should be looking at. But before we do that, let's talk about who we are. For all of you who don't know, Grindr is essentially a mobile dating platform for gay men. We are a Los Angeles-based company, but we are global in terms of our outreach, but also in terms of our staff. So we have a core of our engineering here in our LA office, but we also have a lot of functions that are globally distributed. We essentially go where the talent is. I'm sure you all know how difficult it is to hire the right people in the LA market and San Francisco. It's very difficult for companies to compete. We actually have developers in India, Poland, and as of last week in Argentina. So we're trying to partner with a lot of different companies that can provide us the ability to move very fast. As far as all these different functions like DevOps, development, mobile development, we kind of try to mix it up a little bit. So let's talk about the actual use case that we are going to be exploring today. And as a Grindr user, I want to be able to reliably access Grindr service around the world and to have a consistent user experience. Sounds very simple, but in the next slide, I'm going to talk about what that means. So this diagram shows you where our users really are, and that's important because I also want to highlight organic growth. So Grindr does not have a marketing department. We don't have a marketing staff. We don't do any marketing campaigns, which means that all our growth or our success have been due to the fact that our service has been awesome, and also we were first to the market. So we experienced growth in the United States, South America, Europe, and then through the rest of the world, and it's really organic. Now, majority of our users are in North America, followed by Europe and South America. If you were to add those three markets together, that's probably 70% of our user base. All that growth happened in the last 5 years. In terms of the actual countries count, as of last month, we've actually had users in over 200 countries in the world. And as far as the app is concerned, we have over 40 million downloads across iOS and Android. Now, all this traffic from around the world today ends up in one place, right? So our infrastructure is a cloud-based infrastructure. We are very heavily using Amazon services to do what we do. But all these users end up essentially in one place, right? And when we talk about the scale, let's talk about scale. So we talked about we've got a whole bunch of millions and millions of users around the world. And let's talk about, in terms of scale, what does that translate to in terms of the actual pressure that all these users apply on our infrastructure. So our our peak is around 10,000 API calls per second, and that's a typo. Let's fix that. Maybe later. Our chat messages per day peak is around 85 million messages per day. We also exchange media, so our users exchange a lot of photos, and we do that about 2 million chat images per day. And in terms of updating profile photos, we're talking about 30,000 profile images uploads per day. And as you can imagine, that's a lot of pressure on the infrastructure. And all this traffic ends up on the east coast of the United States, which results in interesting measurements when it comes to latencies. So if you look at our latencies, if you are in the United States, you are okay. Our response time is very good, but the further you move away from east coast of the United States, now you start running into trouble. And if you recall the previous slide, when I talked about where our users are and this organic growth, this very much correlates to the latencies that you can observe. Right? So one thing that I want you to take out of this is that when you're applying an app, mobile application, and you're actually planning to deploy it across the world, then you need to plan essentially accordingly how you structure your cloud mobile architecture to power your clients. Because if you don't, if you have all the traffic ending up in one place, then you need to realize that network latencies stack up very fast, and the user experience is not going to be as good as, let's say, in the United States, right? So, if I'm a guy in Australia and I'm trying to load the Cascade, my experience is much, much different than a guy that's, let's say, walking down in LA. So, going back to the use case that I'm trying to satisfy, my goal is to have a consistent user experience across the world, right? So how do we achieve that? The good news is that Amazon offers you multiple data centers across the world. Their infrastructure can support our infrastructure that we want to build, right? Now, I got a couple questions like, why wouldn't you want to, manage your own data center? Why wouldn't you want to, let's say, run your own hardware and all this other stuff? You can do that, but I think that when it comes to the overhead that brings to your organization, it's really not only cost prohibitive, but it is very difficult to assemble a team that will be able to do that on a global scale. Amazon can do that because they're a very large company. They've been doing it for a long time, and I can tell you that as far as strategy is concerned, when we look at Grindr, I want to leverage as many partners as possible to essentially enable my engineering team. So we can focus on building things that are core to our business, that make us competitive, right? Like features. But when it comes to things like DevOps, infrastructure, obviously that's necessary evil in order to compete. But I want to partner with companies that can enable me instead of me going out there hiring staff, managing all that infrastructure ourselves, right? So we do that in a lot of different areas, but DevOps and infrastructure is one of them. It's a good example. So we talked about, as a goal of this, to start talking about some of the technologies that are able to enable you multi-data center deployment on a global scale. So first thing is obviously Amazon Route 53, which enables you geo-routing, right? There are other solutions out there that can enable your geo-routing. But if you are an Amazon customer, the good thing is that Amazon has a lot of these tools already for you to use. So you don't have to look for other companies, other DNS services. They have that. So Route 53 enables you to essentially set up your infrastructure in a way that you can start now routing traffic from geographical locations to the closest data center to you, right? And also you can start setting up other policies, like, for example, you can have additional policy that looks at how busy the data centers are. Because sometimes in this deployment, maybe the closest data center to you is not the best one to respond. So you can kind of play around with these policies and set them up accordingly. So this is kind of a peek into the future. We are actually working on this infrastructure right now. I would say in the next quarter, this is going to be a reality with additional one, which I don't show you, this is the old slide, in Sao Paulo. So we will most likely have a data center in Sydney, in Singapore, in Ireland, and Sao Paulo. And what that's going to enable us to do is essentially start shaping the world traffic in a way. So if I hop on a plane from LA, so in LA I'm going to be talking to US East. But if I hop on a plane, let's say I fly to Sydney, then I'm going to be talking to the data center closest to me, right? I want to show you what that does. And again, this is an old slide, so Sao Paulo over there would actually allow me to have the same response time in South America like I would have in North America. Right? Now, one thing that I forgot to mention is that, yes. So before we go further, what are some of the problems that we need to face when we're setting up? So obviously, shaping the network traffic so it actually ends up in the data center closest to me is one thing. But now, because I have all these different data centers, my engineering complexity goes up because now I need to think about how do I replicate my data across all these different locations, right? So we'll talk about how you can do that. There are various different ways to do that. Amazon has services that can enable you to do that as well, but it's not an easy thing. One thing from the perspective of the behavior of the application, when you're setting up infrastructure like this, you need to understand what that means in terms of data availability in different geographical zones, right? Nothing happens instantaneously. You need to start accounting for delays in traffic, delays in data replication. When you're building your architecture and you're starting to design, let's say, your transactions, you need to account for that, right? And there are different models that can help you to do that. So going back to essentially this multi-data deployment. So we've actually done this in the last month. We've actually simulated our current production traffic and then also routed current production traffic in this topology to kind of measure what kind of response times we would get. And roughly we've observed that if we actually go with this infrastructure to production, we can essentially ensure the same response times from users in the US currently all around the world. And that's kind of the whole idea, right? The reason, again, why we want to do that is because Grindr experienced a really, really good organic growth. I think we have phenomenal offering as an app. But when it comes to app usability, response time, it really, really matters, right? If I'm in Australia, and it takes me 5 seconds to load the application or get any data, users are like, what is this? I'm not going to use this, right? I think that in our world today, where we use our phones so much, we kind of got spoiled. We are not going to wait. We need data right now. We need applications that respond right now. Any sort of delay is essentially costing us business because users will move to some other competitor who is local. Okay, so let's talk about actual technologies that we are using to this, and this is actually not what's going to go into production, but it will give you a good idea directionally what type of things you could be looking at, right? So, so let's talk about what we are using today, right? Today we're using Amazon Elastic Cache, we're using Amazon SNS and SQS, Amazon RDS, Amazon DynamoDB, and MongoDB, right? All that stuff is set up in our US East region, and when it comes to deploying this infrastructure as a phase one, we very quickly realized that this stuff is pretty hard. It's not, talking about it makes it easy, but when it comes to actually setting up, let's say, a database that has multi-master replication underneath it, it's fairly complex. So as the first phase of this project, we said that all our writes will still end up in one data center. So if the user is saving their profile or doing any sort of changes, all that information is still saved in one place, right? But then when it comes to caching that information and bringing it as close to the user as possible, then we essentially fanning it out and replicating that data. So all the reads can actually happen from these locations, right? And so if you look at actual stack that exists, let's say in Sydney, in Singapore, in Ireland, and also Sao Paulo, you would essentially have all the reads being served from there. The data is replicated from the US East region through essentially PubSub system that uses Amazon SNS and then queuing system. So the way it works is that each data center registers itself with the topic. So we've got all these different topics for data set up in US East region, and then they just get that data as a replication, right? So that's essentially what phase one is. Now, a couple of things to think about here. So this is obviously not ideal, and the reason why it's not ideal is because if my US East region goes down, then everything stops, right? So this is not fully tolerant design. Ideally, the way we would want to set it up is that each of these data centers should be able to be autonomous, right? In order to do that, that means that all these different pieces of technology on the left need to be capable of standing alone and also replicating data between each other, right? And that is easier said than done when it comes to technologies like MongoDB. I'm not sure if you guys ever worked with MongoDB and tried to actually scale Mongo and do geo-sharding with Mongo, where you have one shard set up here, another shard set up there. It's very difficult to do, right? Mongo is a very, very powerful technology, but from the perspective of DevOps overhead and actual configuration, you need experts to be able to do that. That costs money. If you partner with ChangeN to have, let's say, enterprise support, that also costs money. So what are the options, right? I'm sorry, I think I skipped the slide, but no, we're actually talking about it. Now, we also use RDS. I'll list that RDS by itself doesn't have a multi-master replication ability. It's a SQL database. It's a little bit older technology. So again, if I wanted to say, hey, I want to stick with my RDS and I want to have then multiple RDSs, it's not as easy to do. Now, I didn't talk about latencies. At the time when this was written, the replication latency was around 30 seconds of data. So again, I talked about architecture, what the expectations are. If you're replicating data and you have maybe some transactions that are depending on that data to be in certain place, then you need to design your code, you need to design your application so it's fault tolerant for these delays. Okay, so let's talk about what the plan will be, right? So we talked about RDS and Mongo being not necessarily ideal for this situation. Again, you can do it if you want to, if you have the expertise, if you have the staff, if you have the relationships, you can definitely achieve the same thing with those technologies. But ideally, you know, from my perspective, you want to leverage as many managed services as possible. Because again, it reduces your DevOps footprint. You're now extending your engineering staff with experts who do it every day, and that drives your complexity, the complexity that you need to manage now. So ideally, this is what we're driving towards, right? We want to have data centers that are self-contained, which means that, you know, let's say if I have all these 5 deployed, and let's say something happens to São Paulo, and São Paulo goes completely dark, then I want my infrastructure to essentially pick up the slack, right? So I want essentially traffic from South America start being routed to maybe US East, and then Europe, and then, you know, there will be some sort of impact to the users as the infrastructures are spinning up in these other data centers, but at least, you know, you don't have a situation when everything is down, right? The technologies that, from the Amazon perspective, the technologies that are very good for this type of setup is Amazon Elastic Cache. You can set up Amazon Elastic Cache together with Amazon SNS and SQS in a way, so you have these topics and pub/sub type of architecture where data is being sent to different data centers. And then also Amazon DynamoDB is very attractive. Amazon Dynamo supports multi-master setup, and you can configure it in a way so you can have multiple masters taking writes in each of these regions, and then there's a way for you to synchronize and replicate data. Right? One thing that I want to also talk about is static content, and that's more applicable to like mobile web technologies when you're using HTML and JavaScript. However, for native mobile applications, it's also important, especially if you're doing a lot of media, right? If you're dealing with pictures, video, all that type of stuff. There are essentially content delivery network technologies out there. There are various different companies that can enable you to do something very similar, but for that content, right? Edgecast, Akamai are probably the top 2 companies that deal with this stuff. There's a whole bunch of other vendors that also can enable CDN for you. We are using Akamai, and the reason why we're using Akamai is because of our global presence, right? There are some companies that specialize in certain regions, right? So there's, you know, if you're only targeting, let's say, South America, Akamai may not be the best choice for you because Akamai is global and their pricing is global and all that stuff. And they're not going to be as good as, let's say, CDN vendor that specializes in South America, right? But the good thing with Akamai is that they have a global presence. As of today, I think they have 120,000 different POPs. So we have 5 dots on the map. They have over 120,000, which means that they replicate all your state to those different locations, and they bring your data as close to your application as possible, right? The next thing for CDNs is actually having a presence within mobile networks. So if I am, let's say, AT&T or some other cell phone provider, you know, today if I'm on my phone and I'm communicating with a cell phone tower, in order to get my picture or video, I still have to go outside of that network and then hit the edge on the CDN to get it. And that's that last mile. So a lot of CDNs are actually trying to work with cell phone providers to bring their caching infrastructure within the actual cellular networks, which would essentially translate to having literally cache servers right by the cell phone tower. So if you're driving on 401.
So do you have different threshold for different kind of data replication? Because right now at CDF, the data
you have architecture that requires, let's say, some data is more sensitive and needs to be more real time, then you could try to set up replication policies that allow you to do that, right? So you could, for example, shape network traffic and cannibalize network and give something a priority if you wanted to. But we have nothing for that. Okay. Yeah, there may be use case for some applications where you want to accomplish that, right? I think another interesting thing that I want to talk about here is also using CDNs for caching of your RESTful API. So what I want to talk about is if let's say I have an endpoint that provides data to the application for my profile information, right? So when I look at that endpoint at Grindr, it's mostly reads, right? So it's a high read, low write type of thing. And if you think about it, it kind of makes sense because you come in, you set up your profile, and then once your profile is set, you're not going to be changing it as much, right? So for transactions like that, where you have high read, low write, you can start exploring essentially trying to leverage CDN infrastructure to deliver your data. Because at the end of the day, if you have RESTful APIs that serve JSON content, it's not any different than JavaScript or HTML and other stuff, right? But the problem is that if I, let's say, start configuring my CDN to now start caching my JSON objects, then what happens if a user updates the profile, right? Then you have a problem because now the data is spread all over the world and it may take some time to get a refresh. And how do I get a refresh on such a global scale? So you need to then start working with CDNs that essentially allow you through their APIs to invalidate one object, right? And not CDNs do that. Akamai does. So let's say if I were to cache my profile, I can actually tell Akamai that, hey, invalidate this profile object that you've cached, and then what happens is that the information gets invalidated. Next time the user comes in and tries to request that profile, the profile will be actually fetched from the origin server, from the edge, and then cached. So that's another way to kind of leverage, again, CDN infrastructure to cache your RESTful APIs. Okay, let's talk about technologies that we use for all that stuff, and then we'll do some questions. The stack that will be enabling all this is built on Java and Scala. We also use Erlang. So between Java, Scala, Erlang, managed services like Dynamo, SQS, SMS, you can essentially accomplish that. You can accomplish it with a bunch of different technologies. But my philosophy is that I would be very hesitant to build something like this on Node, for example. Reasons for me are, Node is fairly new technology. If I want to hire experts who have done this many times and have done a lot of enterprise deployments, it may be very difficult for me to hire those people and compete with other companies, right? So I much rather use Java and Scala because I know that Java has been around for a long time. There's a lot of people out there who has done some pretty interesting high volume, high availability deployments, and it's easier for me to find people. We're using Node and Angular for a couple of web type of stuff, but it's not as high of a traffic as everything else. Okay, so any questions on this stuff? Yes.
So when there are multiple transactions happening within a single profile, for instance, let's say a conversation,
Yeah.
how do you, if you're replicating or if you're going through another city, how do you keep them in order? Are they numbered?
So you're talking about so the question was, how do I replicate, let's say, profile data in a situation when there are a lot of different updates? master setup, you write always to the right one place. It's not like you're writing a whole bunch of different places, right? So in our let me go back to the diagram here. So in our setup here, if I am, let's say, in the United States, then my updates are going to end up in the US East region, right? So even if I hop on a plane and fly somewhere else, let's say I fly to South America, by the time I get there, the data is already replicated, right? So for our use case, because our users want the data that's geographically around them, it's much easier, right? I'm not a banking application that requires, my transaction to possibly, have like a multi-commit where I have to make sure that each data center is ready to commit and then I commit, right? For us, it's a little bit easier because I know that as a user, it's impossible for me to, let's say, update my profile in New York and then 5 seconds later be in London and try to retrieve it. It's going to take for someone to get there, right? But if I were to have, conceivably, I don't know, 100 data centers, then that problem will become more apparent.
Now, how about the regular conversation chats? Do they not go through the same process?
So those are, yeah, so the chats would go through the same process, and essentially what we're using Mongoose IM, which is essentially Erlang-based XMPP chat server. So XMPP is a stateful chat protocol, and essentially there would be a high availability pair in each of the data centers, and they're aware of each other. So when I'm in New York and I'm talking to people from within New York, I'm being routed through the XMPP infrastructure in US East, and then I fly to Sydney, and then I meet a bunch of people, right? And then I talk with them, and I'm using that infrastructure. But then I'm like, oh, let me chat to my buddy in New York. Well, this guy knows about routing over there, and essentially what's going to happen is that chat message is going to be sent over there, and then distributed to the users. That's how it works. Yes?
How are you tracking performance as well as latency and time for usage as application logs, or are you using service to manage?
You know what, that's a good question. I think we've actually used application logs, but I will ask Ben. What did we use to track the network latencies? What tools?
We use a bunch of different ones. Datahub is one thing. Use external agents like
Yeah, I think Pingdom is an interesting one because I remember when we started setting up our monitoring infrastructure, you got your standard, Nagios and New Relic or whatever. But we really were interested in knowing what the responses are from around the world. So Pingdom is actually a service that allows you to do that. So you can start monitoring your transactions from different different parts of the world, and the way they do it, they actually have servers in those parts of the world, and they will try to ping your infrastructure from those locations. So again, it's like it's a managed service, right? So you don't have to set it up. You could do it yourself. I mean, if you wanted to, you could actually, in different data centers through Amazon, you could set up servers that they are pinging your infrastructure and start measuring yourself if you wanted to. Any other questions? Adam? Okay. Short and sweet. More pizza, more beer. Thank you, guys.